Okay, so last time we were talking about um, starting to think about our implementation of an object-oriented language, right? And if we think about object-oriented programming languages in general, we've talked about so objects are collections of three things, right? What are the three things that go into an object?
Fields.
Fields,
Constructors.
constructors. So we need the ability to hold information about an object. We need the ability to have functional operations on objects, and then constructors for initially building our objects. These are the things that go into objects. So from the book, they're creating kind of, this is like an example of a generic high-level programming language, where we have a class, and notice that, and if you remember when we first look at classes in Java, I actually say there's this like invisible thing called extends object in there, and I take it out saying we don't need it, but they're showing it here. So we have a class called C1. This guy extends this top level object. That is the thing that is the most generic form of an object. That's what we talked a little bit about last time, right? Okay, that is the primitive that's required for object-oriented languages. Okay, so that's our keystone here. We need to have that beginning point that everything else can kind of build off of. We looked at what objects look like, and we did it in Java last time, right? We looked at the object class in Java, I think, and saw, it has some random stuff in there, but, very generic, has a two-string. That way every other class that ever exists, we can trust it'll have a two-string method, because at the very least it's going to get that kind of stuff. But, for us, we can, we don't have to even have anything in there. We can just say everything comes from this. You just have to have a starting point, and then you would add some features to it that might be common among all objects, something like that. All right, so this guy has a couple of fields, X and Y. It's got a couple of methods. Now notice here, and this is similar to some languages, in Java we advertise that methods and constructors are separate. Some languages meld these two together. So for instance, in Objective-C, there is not a functional difference between a method and a constructor. Naming convention wise, Objective-C, usually you call your constructors init with something just because you're initializing it, and that kind of is a reasonable naming convention. But in Objective-C, a constructor would look something like ID init with age int age, something like that. So this is a method that takes in an integer for age and returns a ID, which is a pointer. That's what he's going to return. And the body of this guy, the very first thing that you'd have in here is you'd have self is equal to super. She might even have super.init. And then you'd have, probably self.age is equal to age. And then you would return self. That's what a constructor would look like in Objective-C, where you always have this sandwich. You build yourself in terms of your parent's constructor, and then ultimately you return a pointer to yourself. 100% of the time in a language like Objective-C, that's what the first line of your constructor will be. That's what the last line of your constructor will be. So we can kind of see that's why Java removed those pieces. If it's always going to be the same first line and it's always going to be the same last line, why make you write the first and last line? Okay? But Objective-C tends to be a good teaching language from that perspective, because it, is showing us how we are actually getting the variable self, which is the same thing as this in Java. All right, questions about that? Go ahead.
How does it know to run that constructor when you create the new object if it doesn't have the same name for each one of them?
Oh, you actually build it by calling the constructor. Yeah, there's not a generic syntax for the constructor. What he's asking here is, when I go and build one of these guys, in Objective-C, I would say, let's call this guy a person. I would say person pointer p is equal to let's see, it would be init with age 15, Alex, something like that. So we will allocate memory for we're actually sending a message to this. That's going to be related to what we talked about today. So this is person init with age 15. This will allocate new memory for this, ultimately returning the ID that was associated with this guy inside of a variable called P. Yeah.
So the ultimate parent class, how does it know to initialize something? Because the initialization is what gets everything else going.
Yeah, so in Objective-C, if we're just going to keep going down this path, I would have a class called person that inherits from object.
Right, but then like what I'm saying is so object has an initialization that's then creating that person object below it.
Mm-hmm.
How does that initialization method essentially get everything going? Because
You mean how's this guy written inside of object?
right.
Yeah, so I mean that's going to be part of your language implementation. That's not something we do. That's that primitive. What does it mean to build a completely generic object?
Okay.
You know, and that's where you'll get that initial kind of, I don't know. Just,
The starting point.
yeah, the little hook that everything else will be built on top of.
Okay.
But yeah, that's the language implementation side of things. That's not, at some point the programmer has to rely on that piece existing. Okay, so in a language like Objective-C, there isn't a differentiation between methods and constructors. They're one and the same. Constructors, they always return a memory address. But in Objective-C, you actually say, this is the name of my constructor, this is the kind of value it returns, even though it will always be that value. Every single time I'm writing a constructor, I will put ID in front of it, because that's the kind of value it returns, an identifier for that object, which is effectively a pointer. So a more modern language implementer might say, well, if you always construct your objects using method-like things that always return an identifier, maybe we don't make them return the identifier. Maybe that makes sense, right? Quality of life, convenience type of thing. But then what do you have to do? You have to have a way of differentiating the constructors from the methods, right? So what does Java do? Java says your constructor must match your class name, case sensitive and all. Other classes or other languages will have the constructor always called init, something like that. You know, so at that point, by giving you that quality of life thing, by not having to pick the return type, they're effectively saying, well, now we need to have a way of telling whether you're talking about a constructor or whether you're writing a method. And we're going to do that by saying constructors are always called this. We can make the argument that I'm not sure that's better. Maybe you'd rather name your constructors whatever you wanted and just have to have the return point type for identifier. I don't know, probably depends on the programmer. There's probably an advantage if you look at Java or C# code to be able to, at a glance, be able to see what the constructors are. And they just all match the name of the class. We could probably say that's better, but it certainly hides a lot of the stuff from you. Make sense? So this is true, this top thing, that objects are collections of three things: fields, methods, and constructors, but every now and then methods and constructors are melded together. So you'd always have at least fields and function-looking things as your other entity/entities. All right, questions on that? So that's what an object is, right? That was what an object was when we first learned object-oriented programming, and that's what it is when we're thinking about writing an object-oriented language. All right, so here's some example of non-language specific code. This could be Java, whatever, but you know, we see that we often use the keyword class. You have your class name. This guy extends object. So that's that evidence that everything comes from some top level guy. We have a couple of fields here. We have some methods here. In this particular case, they're treating constructors as methods. We'll see when we get to the actual grammar for the language, which I have a couple slides down, whether they differentiate constructors versus other things. My guess is they do not, since they have the same flag in front of all these method. So it's entirely possible they force us to name and initialize. So they basically say there is a special kind of method or a special method that must be named initialize, and he's treated a little bit differently. He's kind of royalty, something like that. Okay, so we got some methods in here. Similarly, another class. This class extends C1, which is this guy up here, which happens to extend objects. So that's kind of your inheritance example. Has some fields, has some methods, blah, blah, blah. Now, so this would be a definition of a couple of classes. And then we have a let. So let creates a local environment. So in our let, we're creating a local variable called O2. And this guy is a new C2, which is this guy. And since he's a new C2, and this is the way they're implementing that syntax, the grammar for our language is very likely going to say initialize must be the name of the constructor. Do we have an initialize inside of C2? Yes, we do. Where did it come from?
C1.
C1. Okay, we didn't specifically give C2 a initialize, so he inherited from C1 and got C1's version of initialize. Go ahead.
So why is field Y in C2 if it inherits that from C1, and you can get X from C1?
Well, so you're asking why does,
Yeah, why did they?
because they wanted a different field Y. This field Y shadows this field Y. All variables, including as well as methods, always resolve to their most local definition. We start crossing between objects, same thing's true. We'll check the definition of the current object. If we have a field called Y in the current object, we're not going to look at the other guy. This one shadows it. Similarly, if we had a more local initialize here inside of C2, that's the constructor that would be used. But since we didn't find it locally, we're going to search one level up. And if we don't find it inside of C1, we'll search one level up with it, which is inside object. If we don't find it there, we start screaming and yelling. You know, we've run out of places to search for them bed bugs. All right. So, questions on this? Oh, actually, I want to get down to the send thing here. So, you know, this is kind of our normal let environment. We create an instance of our C2 object, C2 class. And then, you know, they're creating, you know, they're saying here's a begin thing similar to our previous lot. So that's our block structure, right? That's our begin end. So we're going to let this variable exist in the local environment that is housed inside of this begin end. We're just kind of rolling with their syntax here a little bit. Now, notice what they're doing here. They're calling the way they're calling a function. So, for instance, set x1, set y1, set y2. The way they're calling these is by sending a message to this guy, to this object. Okay, so this object is an instance. So O2 is an instance of C2 here, which is a instance of C1. Well, he is a C1, and he's just a little bit more. So the way we call his setx1 method is by sending O2 the message setx1 with the parameters. Make sense? So this is a message passing implementation of object orientedness. The equivalent in Java would be O2 dot setx1. Make sense? But ultimately what we're doing, and they try to really expand this out by the way they're writing it, is we are sending a message to this object. What message are we sending? The message that is call this method. We're telling that object what to do. And Java works the same way. Java just gives us that dot notation to maybe be a little less verbose. All right, so we're calling a couple of functions here, and the way we call them is by sending messages to our objects. I don't know what they're doing with this list.
I want to output something.
Yeah, so that must be their way to do the output. So they're saying get x1, y1, x2, y2. They're sending those messages to that object, and ultimately it's going to boil down to, I'm guessing this will just create a list of those things. So your output of your program will be the list 101, 102, 101, 999. All right, questions on that kind of a high-level object-oriented syntax that is Java-esque, but kind of is written in terms of like these lets and this kind of new thing of message passing? Go ahead.
I was curious, in like the recursive nature of Scheme, are we able to implement like return statements to have it like stop after a certain point and just execute? Because you don't have you're in a method, if you have a return statement, it won't execute the code below it.
You can make, well, so when you think about what does a return statement do, a return statement makes a method, makes the function immediately end, and optionally can return a value. That's what a return statement does. There is a way in Scheme to make something end, but I don't think returning a value makes sense in Scheme, because Scheme is kind of built on top of this idea of things boiling down to a first-class object, which is a value. But there is a way to like break out of the current logic. I don't remember what the function name is, but there is something. And part of that is less about Scheme and more about the differences between functional languages and procedural/object-oriented languages. I mean, functional languages, as you saw in the first half of this class, as you're working with Scheme, you had to kind of remap your problem solving to think in terms of a functional language, because you're used to more of a linear or even object-oriented approach to programming, and it doesn't really work that way because you're thinking about things in terms of the answer of the next guy. Yeah.
When I was looking at the object-oriented page on Wikipedia, it listed Lisp on there.
Lisp is Scheme's a superset of Lisp.
Right.
Yeah.
So, I guess, could we maybe talk about how that even makes sense?
Well, so what does it mean for a functional language to also be an object-oriented language?
Right.
Well, we just saw it. It would be a language that supports the creation of classes, but it would still be functional in terms of how you wrote the syntax for the language, how you use things. So what we're looking at here would not be indicative of a functional language. This would be an indicative of a high-level, we call it an object-oriented language. I think that's where you're getting at, is I'm referring to the difference between these three language paradigms as being object-oriented, procedural, and functional. Whereas can a functional language also be an object-oriented language in that can a functional language support the concept of objects? So maybe when I'm saying you have object-oriented languages, I'm really talking about a high-level language that's written in an English-type way that focuses on the modular pieces of objects, as opposed to a language that happens to support the concept of objects.
Okay.
So, if you broke it down in that way, you would say that a functional language is a language whose syntax is defined in terms of function calls that boil down to values. Where, I guess by my definition of a procedural or object-oriented language, these guys typically are English-like statements that may have an impact on the environment around them. And that's how, so rather than relying on the boiled down value to be passed into the next thing, you can have a statement that stands on its own that might just change the environment, change the current state of the environment so that the next line actually does something different. I think those are maybe the differentiating factors between functional languages and, let's call it, non-functional languages. Maybe that's a more fair way of putting it. Okay, so there's that example. Let's see if this guy gives us anything more interesting. I think, is this one just, so we're sending the message get color from color point. Oh, yeah, he has get color, so this doesn't really show us anything interesting. Just a kind of a different example of what we just looked at. All right, so here is a potential grammar for our new interpreter. All right, so we have the concept of a program, where a program is a program is 0 or more class declarations followed by the program body. All right, so a little bit different than what we typically conceive of with like a Java, where we're saying, okay, well, you know, we can have classes that can live in different files, and then we have our class where our, you know, main method lives. And that's where everything kind of begins and ends, is inside of main. You know, and that kind of takes the gets that idea from C, you know, the C-based programming language. So in this program that we're creating, our interpreter here, what we're actually doing is we're saying, okay, we're going to have a program, and this program is going to be a bunch of class declarations. I have 0 or more class declarations, so I don't know if a bunch class is equivalent to 0, but you know, 0 or more class declarations followed by the body, the logic of my program where I'm going to use those. So if we're kind of thinking about this in terms of our previous thing, followed by a lambda calculus expression, where more than likely that guy is going to be one of our block expressions, where we have a whole bunch of lines of stuff, something like that. We'll see what they mention here. All right. So then what's a class? So a class is, and we'll probably still write ours in terms of lists, rather than work on a parser that pulls, that allows us to deal with like English-like symbols, strings in Scheme, and then pull out the pieces. We'll keep doing lists, so we're already familiar with cars and cooters and that stuff. So this guy would likely be a list whose first element is the word class, whose second element is an identifier. We probably could say something like symbol, you know, where it's the name of the class, and followed by extends, and then the name of the class he extends. Where in the baseline, if he doesn't extend anything that you wrote, he would extend object. That's where we have that assumption that there is a top level object that exists. We didn't write it. We didn't have to write it. But if this guy right here says object, that means he is a plain Jane baseline class. That makes sense? But with this syntax, we're able to say that every single class we ever create extends another class, with the understanding that there is a top level class called object. All right. So then we'll have a 0 or more fields followed by 0 or more method declarations. That's what builds a class. Make sense? So that kind of goes hand in hand with our, what is a class? A class is a collection of fields and constructors and methods, where in this definition, they're melding constructors and methods into a single animal, just called methods. All right, that makes sense what a class is? All right, so what's a method declaration? A method declaration would be, again, we're going to say this is a list. So this is going to be a list whose first element is method, whose second element would be the name of the method, followed by a list of 0 or more identifiers. So what does this guy remind you of? What should he remind you of from our previous...
Lambda expressions.
Yeah, these are effectively lambda expressions, right? So we have, except lambdas are unnamed functions. This is now a named function. So we have a method that has a name, that has 0 or more parameters, and here's the body of that guy. Make sense? Okay. So what's the advantage of having a name here?
You can call it more than one time.
Okay, well, we were able to do that before by putting it into our environment, right? We stored it inside of a let. If we look back at this previous example, I think this one will be good enough. We said let O2 equal this object. And when we have the new keyword here, that instantly says call the function called initialize. That's the logic they're using here. All right, so let O2 equal this. And then inside of here, so we don't have the ability in here to let C equal some method, or at least not, they're not depicting that. That methods that live, what's the difference between, historically, what's the difference between a method and a function?
Methods are part of classes.
That's it. Methods are part of classes. So if we look at the history of function-like things, way back when we would have had something like called subroutines. And some languages call them subs or something like that. And then from there, we kind of, let's say, evolved into functions and procedures. And actually, I'll go ahead and then from there, we kind of have this thing called methods. So functions, these typically returned a value. Procedures did not return a value. So that's what differentiated those guys. Were subroutines, let's just say they just were. All right, so they went from subroutines to this idea that, okay, well, the idea of a subroutine is we want to have this automated way of doing something, right? And what we'll do is we'll go ahead and split them into two different categories. One category that might give you a value, and another category that never gives you a value. From a language development perspective and a language use perspective, there could be some benefit to that, right? We might say, oh, well, I can write this function that might return a value. Well, that will return a value. If you're going to write a function, you're going to return something. I might write that guy with that in mind because somebody else is going to have to do something with that value we're returning. Whereas a procedure is just going to do something but not actually spit anything out in terms of a returned value. So I can actually treat that different at the implementation stage, even if these guys have a whole lot in common with each other otherwise. Make some sense? So methods took away that mapping where methods may or may not return a value. So we would say that methods always have a return type, and if you don't intend to return a value, you'd make the method of type void, right? I'm not returning anything. So the way we build functions out of methods is by making the return type something. The way we build procedures out of methods is by making the return type void. All right, makes some sense? This is presuming we're in a strongly typed language, as opposed to a loosely typed language where we don't even have return types. We just say, look, this guy's going to return something. Maybe. And if he does, deal with it. Well, and then that's where you have, like in a language like Python, if you try to grab the result of a method that doesn't actually return a value, you get the default value is none. Like, I got nothing for you. Here's nothing. Like, look, I'm doing you a solid by at least saying you can test this to say, do I have nothing, right? They have a null value in Python called none. It says, look, if I got none, don't try to do stuff with it.
It's more zero than zero.
Yeah, but at least we can ask. We can ask, is this nothingness? Which in and of itself is similar to this idea of that primitive object type. Our modern languages, we have some assumptions that testing for nothingness is there. Is something equal to null? Is something equal to nil? Is something equal to none? Whatever the language chose as their, verbiage for nothing, right? We assume that our modern languages have that in there because we don't want to start sending messages to nobody, right? Because then we have the human version of talking to the wall, right? Which I do as a hobby, but it's like funny, right? I do have pretty long, drawn-out conversations with Mr. Gonzalez at home. we'll be in like a room just talking away. Other humans aren't around. So my wife will walk in like, who are you talking to?
So you use him to rubber duck life.
Mm-hmm.
I was just about to say, yeah.
Yeah.
Does he respond back?
Yeah, but I only speak his language.
Okay.
See, he only speaks.
So you don't speak for him, but he speaks to you.
He speaks to me.
Okay.
Yeah.
No.
I see.
I wasn't sure if you were mouthing a voice for me.
As Blaine shifts back 2 feet. I don't want to catch that.
That wouldn't be too bad. I just want to catch the bed bugs.
But I am aware that he's real and everybody else is just missing it.
Everybody else is singular.
Everybody else is missing the Mr. Gonzalez reality show. I'm just special that I can hear him.
Oh, you're special, all right.
What's this?
Is he here with us right now?
No.
No. Why do you
He's
ask
not
ridiculous
omnipresent.
questions?
Yeah.
He's not omnipresent.
Hey, what
Yeah, come on.
like, see, there is a such thing as a stupid question. Well, just in case our Ann Arbor folks didn't realize, what happened to the other one? We took away the normal Gonzalez?
It should be on there. Yeah, no, it's there. Gonzalez shirts. The fast one, it goes fast.
Oh, it's just not right next to it, I see.
Yeah.
Yeah, so we actually have a Mr. Gonzalez emoji.
Did somebody make that?
Yeah, Blaine and Blaine's girlfriend.
That's impressive.
I know.
That is her name.
I can actually say her name, but I can't spell her name.
Yeah,
Siobhan, right?
There you go.
It's spelled all Irishy.
Yeah. I'll give you 500 guesses that spell that name. You're not getting it right. Unless you know the name and you know how to spell it. But if you look at it, nobody would pronounce that Siobhan. It's just not in the cards, is what it comes down to. Yeah, so I guess digitally, Mr. Gonzalez is here. But, yeah. He's still waiting for somebody to make him a new Hawaiian shirt that was lost in the bedbug war of 2019.
The war that cost you the furniture.
What's this?
The war that cost you the furniture.
I don't even care about the furniture. You know, that makes her feel better. I mean, I have dollars, thank God. So it's buy new furniture, get the really nice lawn furniture. It's fine. It's just to get this like the high end plastic. No bed bugs living in there. That's 6 inches thick of solid urethane.
No, it's too soft.
They
They can burrow in.
can burrow in.
We need steel.
Your whole house just made of. It's actually poured steel. You bring this like special group in from Romania, is out in your front yard boiling steel.
Cast iron furniture.
Have you seen that YouTube video of the weatherman who in real time his the Weathercast went crazy and the temperatures? Have you seen that? No, all right, this is worth the class time. Let's see. Yeah, let's get the sound cranked here.
Oh my.
We'll bring you on into the temps, and we're all doing okay. Wow, 750 degrees in Gila Bend right now. And 1,270 in Ahwatukee. Now, I'm not authorized to evacuate Awatuki, but this
Cave
temperature
Creek.
seems pretty high.
Cave Creek is really
Yeah, Cave Creek, Fountain Hills, they don't look good either. And frankly, Wickenburg is a total loss. You might as well just get out of anywhere along this 60 years. It's very warm. Surprise is starting to heat up as well at 1,300 degrees. So again, the safe spots seem to be Chandler and Mesa. Scottsdale is doing okay so far, but you're sort of surrounded by some pretty intense heat. So, again, I'm not your dad, but I would get out while you still can. Steel boils at about this temperature, so there's probably nothing left up there right now. So don't even bother looting up there. It's not going to be worth it. But here's the way the rest of the day shapes up. 70.
Isn't that pretty funny how he just held it together? I think steel boils at this temperature. And I looked it up. Actually, steel boils at a higher temperature than that. Well, I did find it very interesting that there is a boiling temperature for steel. I mean, It makes sense when you think about it, but just, it's not one of those things that you would think you'd have like the recipe book for.
I mean, yeah, it's just boiled
Huh?
steel, my favorite.
Is it possible to get to that, like 2,900 degrees?
Yes.
Yeah, I would assume so.
We have to, like
Global warming.
You just chill out in Ecuador and just wait for the steel to boil.
The answer is thermal. Cool down real quick. I suppose you could.
All right, so
Like if you want anything crazy.
now that we've covered the, we really set a new standard for us. We've actually, in a computer science language class, we've talked about the boiling point of steel.
I mean,
Okay. If that's not cross-disciplinary, I don't know what is.
it's becoming a gas at that point. You can breathe it in.
I have iron lungs. Literally.
Literally. I need help.
That's where you get iron poisoning and die.
Yeah, so all our refrigeration will be made out of poured molten steel, but we'll need to make sure we boil it first because that gets all the little air pockets out because they can live in there.
Exactly.
Yeah.
They wouldn't be able to get out of there, but they could still live.
You never know. Nature finds a way, Blaine. The old Saturday Night Live Ditka commercials, or like the Bears. Yeah, the Bears. So what do you think is going to be the score in this week's game? The Bears 217 to -8. Really, -8, Tom? Yeah, Ditka will find a way. We have covered some stuff today. Ditka will find. And then they had the time when they were trying to determine who would win between the Bears and the Bulls. Ditka versus a hurricane.
Also, just as a side note, 2,000 degrees, all the trees will have been on fire for several hundred degrees at that point, because wood ignites at 700.
Well, yeah, but steel's not boiling yet.
Right.
So I don't have my furniture is what you're really saying. So this isn't helpful.
Yeah.
Let's be constructive, people. If I'm not boiling hard metals, I don't even want to talk about it. All right. So again, we have our message passing thing here with send. So this is supported down here in our the idea of our method declaration. So built into an object-oriented language is this concept. When I say built into a object, I mean specifically this object-oriented language is what we're looking at, but this concept of message passing is kind of one of the core tenets of object-oriented languages. We can represent it in different ways. You know, our modern languages typically use this dot notation where if you didn't have this connection where you've seen this message passing, message sending thing, you might not consider it that, but that effectively is what's happening. We are sending a request to the calling object saying, this is what I'd like you to do. And that calling object can decide if he can do it himself or if he needs to go to a higher authority, the person he inherited from. Make sense? So this is what we're seeing here is not really a a choice to not store functions in our environment, because if we have things out inside of our code outside of classes, we might still store lambdas with associated variable names inside of our variable environment. Yeah, that's not off limits here. This isn't an alternative. This is saying we are treating objects, this idea of a class, as this special kind of citizen, and the idea, the concept of a unnamed function doesn't make sense in this context, because we need to be able to send messages to the object. And if I'm sending a call a method message, that method better have a name. Does that make sense? All right, so this is it's a design decision, but it's a design decision that's compatible with object-orientedness. Go ahead.
If I can waste a bit more of your time, are we going to look at the differences, or potentially supporting multiple inheritance, or are we going to solely focus on single inheritance?
So I would say single inheritance. Generally speaking, if you look at any modern programming language, multiple inheritance has fallen out of favor. It's mostly actually so C++ supports multiple inheritance, but any of our modern languages since then, actually I think C# might allow you to have a syntax for it, but regardless.
C# does not.
Yeah,
Okay. Java definitely does not. But you might want to triple check that, because there are a couple of weird things with C# where it allows you to use old school language constructs under a very specific syntax.
An unsafe block?
Yeah. So like for pointers, things like that. But regardless, I think the idea is that multiple inheritance starts getting confusing when you might have two different classes that have the same function in it. And now you're like, well, who do I pick? Who's the winner? So in terms of the constructive use of multiple inheritance, I think we mostly covered that today through interfaces. If you want to have a method that exists in two different things or something, I mean, you probably would just avoid having the same method name. But if you want to meet different standards, if you want to be both a person and a tent, okay, this is
Imagine this in my head.
okay, this is the person tent hybrid. They would be, follow the interface that defines what are the standards for a person, and they would also implement the interface that says what are the standards for a tent. They would participate in both of those standards, as opposed to actually inheriting from a base object that is a tent as well as a person, where, I don't know, they maybe have something that's shared between them. I don't even know what that would be, but let's just assume there's something. They both have a method called X, right? And we're not sure, do you call your tent method X or do you call your person method X? Well, we can do a coin flip and see what happens, and that way it keeps it random. Or maybe it's whatever one you inherited from first. Maybe it's whatever one you inherited from last. That would be a language implementation thing into, what shadows what. But typically multiple inheritance is not something that's, it's I would say among language folks, it's something that is considered to be not a good idea.
Not good ideas. It is in Python.
Okay. Well, there are better solutions to it. Okay. So for Monday, we want to start writing our constructors for these guys. So we want to have a constructor for, I'm going to keep it, we're going to have a constructor for a class and the constructor for methods. So we'll do constructors, predicates, and then the get functions, the conveniences. Keeping in mind that you don't have to know what a body is. You just have to, it takes in the body as a parameter, and we'll build a method out of the body, because the body is obviously going to be built in terms of these expressions down here, right? All right, so we want to have constructors and predicates for program, class declarations, and methods. Sound good? All right, so that is what we'll do for Monday, and then we'll start building this out from there. Questions, comments, concerns, bribes?
just the constructors, not putting them in the language.
Correct. Yeah, we're not building apply expression or anything yet. This is literally just we're getting started with our constructors, where we should be able to build a program by passing it a list of classes and an expression, and it will build a program for me. Similarly, I should be able to build a class by passing it the name of the class, who he extends, a list of fields, and a list of methods, and he'll build a class for me. Similarly, I should be able to build a method by passing it the name of the method, a list of parameters, and the body of the method. And then predicates and the appropriate getters for those. So maybe a method we have get body or get fields, something like that. Make sense? So purely the initial building blocks, no logic, no interpreter yet. Cool? All right. See everybody on Monday.
Yeah, C# doesn't